Hello and welcome to a discussion of data engineering and in general, a brief introduction, if you will. So the idea here is for me to talk a little bit about what data engineering is, why do we do it, how does it work, and what skills are required to do it, and then generally speaking, how are those skills applied. So jumping straight into it, a long, lengthy definition of what data engineering is. It's the development, implementation, and maintenance of systems and processes that take in raw data and produce high quality, consistent information that supports downstream use cases such as analysis and machine learning. It's the intersection of security, data management, data ops, data architecture, orchestration, and software engineering. So a data engineer manages the data engineering lifecycle, beginning with getting data from source systems and ending with serving that data for use cases such as analysis or machine learning. A pretty good definition, really. And that's taken from the Fundamentals of Data Engineering by Joe and Matt, published at O'Reilly. And you can see their names there if you're interested. So definitely worth looking into. So we talk about that data engineering life cycle. That's where you're taking stuff from things that are producing data. These are typically transactional systems such as your ERP, CRM, and so on systems. So a business has some purpose that exists inside of that. They've over the years likely acquired or created systems to help them with their day-to-day operations. Those systems have data in them as a general rule, and that is what we're trying to get into a form that can be used for reporting purposes, really. We start by doing something that's essentially ingestion. That's where you take data from the thing that is making it and move it into a more accessible location so that you can make it better. That's typically where you're doing all the transformations. This is a process of refinement to iteratively improve the quality of the data. And then lastly, it's typically around serving it. And that's making it available for some sort of systems, be it Power BI, Tableau, or whatever, to do essentially analysis and reporting on it. Underpinning all of those activities are things like data management, data governance, data ops, architecture, orchestration, software engineering, and security. Security is very important when you're dealing with an organization's data because it is likely their most valuable asset. So why do we do it? It's pretty much like a supply chain, right? You take stuff from a source that's producing it, you do things to it, and then you hand it off to someone else. We're trying to get rid of data silos as a general rule, and that's where these independent transactional type or data producing systems may not necessarily be terribly accessible by the general population. As such, you want to get them to where they are. That's generally referred to as tearing down a data silo. And it's about getting data into a shared location, cleaning it as you need to, and then basically governing and controlling access to it so that it can be the value that it has can be realized by the organization. The idea is to reach this end state of being a data-driven organization. The idea being that an organization should be making decisions based upon not just their intuition, but rather based upon data. So it's essentially moving to a, if you will, a scientific process sort of approach of coming up with a hypothesis, testing it, and then making decisions based upon it. How does it work? Most systems rely on some layer approach. And in particular, the lakehouse is very simplistic in the way that it does it with three simple layers. But at a general rule, you will hear layers being used. The idea is that you're trying to do mass production, like a manufacturing process sort of supply line where you're going through and doing things in a certain way consistently in each one of those zones. So the raw zone, if it exists, is going to be the data in the native file format. There are times that you don't necessarily use the raw zone because you may be taking data from something like a relational database. There is not really true raw or native file format. Rather, it's a system with a proprietary, oftentimes, mechanism for representing its data. You may export things into a file format, but if you're reaching out directly to a relational system, oftentimes you skip over the raw zone and instead go straight into bronze. The bronze layer is similar to the raw zone in that it's oftentimes the same data. especially if you're dealing with something that truly does have a native file format, such as a CSV or a JSON file. But in raw, you've standardized it into the same data format so that it's more consistent to work with. And that's really all you're doing to it. And then silver takes things from the bronze zone, applies business rules to it, and removes any duplication. And it is at that point fit for use. It is believed to be correct. And gold is created from silver for purpose, right? So you take things out of the silver layer and potentially even the gold layer, combine them together in a certain way to answer a particular set of questions. And that is what a gold item is. So whenever you're using this, what kind of skills do you need? And it comes down to quite a few: data management, data architecture, understanding how data operations works, and data ops, the idea of being responsible for the code, similar to DevOps, versus handing it off to some sort of a maintenance or operational team. Orchestration is controlling the order in which things occur. It's important that you make sure that things happen appropriately, especially in those error conditions. Whenever things are going well, life is good, but whenever things go badly, you need to make sure that your orchestration responds appropriately at a high level process level, not just at an individual activity. Software engineering is underpinning it all because you have code that is running generally in some form. Even if you've created pipelines with a mouse, there's some representation that is essentially code at the end of the day. And then security, where you're making sure that people have the right access and no more, and so on. So least privileges and all of those things we've been doing in security for years. The technologies and languages that are required, SQL is likely the most pervasive data engineering language you will have. It is the lowest common denominator, if you will. It is oftentimes used everywhere. But you'll also have Python, Scala, and other higher level languages. You may have a fair amount of scripting going on, depending upon the environment, using either PowerShell or Bash. And you may even have some traditional programming languages, C#, C++, and so on. And there's almost always these days some sort of cloud platform in the mix. So you may be using Azure Storage, Data Factory, Databricks Synapse, and those sort of technologies. How is it typically done? You work with stakeholders to figure out what data needs to be ingested, or you're proactive and ingest it all with a very low frequency of refresh, meaning that you get what's there initially, and then maybe at a once a month or whatever interval, relatively low frequency, you refresh all of the data, regardless of if it's being used or not, primarily to be prepared for its use. Then you, once you've got those things ingested, you get them into the data lake. And a lake house and a data lake are built upon this low-cost cloud-based storage. You typically refine the data as needed, moving it into the silver and gold layers. And then you make sure that you keep track of what's there with the data catalog. So you have an inventory. You have data quality involved to make sure that it's correct. And then you make sure that you have a way of knowing what's been done to what. So you have data lineage so that you know how and what has been done to a particular data. Another view of the relational or the medallion architecture, we start with a relational file-based system on the left side. We then refine it or ingest it into the raw zone. Your source systems are often transactional, may or may not be, but often are. They may involve changes to existing data as well. So you may have a record that gets updated many times as part of those systems. And sometimes those periods of updates can be quite long. If you consider something like a medical system, a patient may be in a relationship with a provider for years and years. And so things like their addresses and various other factors may change over time. They may change their name. Who knows what might change? Anyway, raw is typically the same source as the sources I've mentioned in the past, but you may sometimes skip over it, especially if you're dealing with a relational system. The bronze is an accessible version of the raw zone. It's append only, meaning that you don't update anything there. You think of it as a journal that is continually being inserted into, typically in some sort of a table format such as Delta. Silver is a cleansed version of bronze. There's no duplication at that point, so there's no duplicates. You take what's in silver, and periodically update it with what's coming from bronze based upon, in the case of upserts, some sort of a key, and ordering it by a date. And then you also apply business rules to ensure that no data is present in that zone that is not valid. And then gold is built for a purpose. So you're answering that question that we discussed earlier. A good resource, as I mentioned earlier, they do a nice job. If you have any questions, send me a message. Let me know. I'd like to hear them. I'll talk with you again soon. And as always, do stay safe.